In the electric circuits laboratory, the fourth experiment is named as THEVENIN'S theorem and maximum power transfer. And the objectives of the experiment are firstly, validating THEVENIN'S theorem through experimental measurements. Secondly, becoming aware of an experimental procedure to determine Thevenin voltage and Thevenin resistance. And lastly, demonstrating that maximum power transfer to a load is defined by the condition when the load resistance is equal to Thevenin resistance. So in the lab, in the experiment, we will use resistors and potentiometer, a board, multimeter, and a voltage source. In the first part of the experiment, validating Thevenin's theorem, firstly, we will see the actual values of the resistors that we will use. So to do that, firstly, we will measure the 3.3 kilo ohm resistor. And this value will be noted. Secondly, 2.2 kilo ohm resistor. We will use the actual values of the resistors. And then a kilo ohm resistor. And 470 ohm resistor. Which has an actual value of 466 ohms will be used. This will be our load resistance. After the calculation part, in part D, turning on the power supply, and we will measure the voltage on the load. So the voltage supply will be arranged as 12 volts. one end will be fixed to ground and the other one is fixed the circuit, as you can see in the figure 4.1. And now the DC voltage value on fourth resistor or we can change the polarity. The voltage value on the load will be noted as 0.81 volts. At part E, Thevenin resistance will be determined. To do that, we will not use voltage source. And one end of the 3.3 kilo ohm resistance will be at the ground. Also, load resistance will not be used. Only the resistance value will be measured. And we will note this value of 2.29 ohms as a Thevenin resistance value. In part F, it says that now determine Thevenin voltage by constructing this network shown in the figure and measuring the voltage again at the same place. But now we need to connect the power supply. And we will note this voltage value as Thevenin voltage measured value as 4.81 volts. In part G, Thevenin network will be constructed. To do that, we will use the measured values of Thevenin voltage and Thevenin resistance in the previous parts. So, as a Thevenin voltage, we will use the value of 4.81 volts. We will open the power supply and set the value as 4.81 volts approximately. And with using potentiometer, we can change a value of resistance between 0 and 10 kilo ohm values. We will use 2.29 kilo ohm value. To do that, middle and the right index of potentiometer will be connected to multimeter to measure the resistance, and the value will set as 2.29 kilo ohms. And the load resistance will be inserted to the circuit as seen in the figure. The voltage value across this resistance will be measured. After the power supply is connected. This minus sign is because of the polarity of the voltage source and the multimeter ends. We can write the voltage value as 5.56 volts. In the part 2, maximum power transfer will be realized with validating the condition when the load resistance is equal to Thevenin resistance. To do that, the circuit shown in the figure will be constructed, and we will use a voltage source as 8 volts. We arrange the source as this value. We will use a 330 ohm resistor. We can see the actual value of it also, and not. It is 370 ohms. And a potentiometer will be used, and the value of the resistance will be changed each time. So firstly, we can set the value as 50 ohms. We can add the resistance value that we use. The voltage value will be measured on the potentiometer. And this value will be noted as voltage value across the 50 ohm resistance value. Power supply will be disconnected. And we will take the potentiometer out and we will set the new resistance value. Now the value of potentiometer will be set as 50 ohms. And when we turn on the power supply, we will note the value of voltage as 1.06 volts. Then the value of resistance will be set as 100 kilo ohm. The value of resistance will be noted. And the corresponding voltage value will be noted as 1.92 volts. Thirdly, the resistance value will be set as 200 ohms. and the value will be noted as 3.07 watts. Then the value of resistance will be set as 300 ohms. And the corresponding voltage value will be noted as 3.87 volts. Then the value of R1 measured, which we measured that value at the beginning of this part, it is 317 ohms. The value of potentiometer will be set at that value. And the corresponding voltage value will be noted as 3.99 volts. This time, the value of resistance will be 400 ohms. And the corresponding voltage will be noted as 4.46 volts. Value of resistance will be 600 ohms. and the corresponding voltage value will be noted as 5.22 volts. Then the value of resistance will be 800. And the corresponding voltage will be noted as 5.72 volts. And lastly, the value will be noted as 962 ohms. And the corresponding voltage value will be noted as 6 volts. In the last part of the experiment, maximum power transfer will be realized with experimental approach. To do that, voltage source of 10 DC volt will be used and a 91 ohm resistance will be used. Before we can measure the actual values of that resistors. And we will note the resistance 1 as 90 ohms. Second resistor will be a 220 ohm resistor. For that, the value of resistance will be noted as 216 ohms. In series connection with the first one. And the third resistor is 330 ohm resistor. Which is having a value of 380 ohms. Which is in parallel combination with the second resistor. And the other resistor will be the one which is having an actual value of 466 ohms in series connection with second and third resistors, with one end and the other end will be at the ground. And the voltage source of 10 volts will be connected to the circuit. And it is asking for the voltage value on that resistor, which is R4. And we can note this value as 6.80 volts. Then a 1 kilo ohm potentiometer will be introduced to the circuit. One end will be touching to the R4 and the other end of the potentiometer will be connected to the ground. Now we will turn on the power supply and adjust the potentiometer until we see the value of 3.40 volts, which is Thevenin voltage over 2. And now we will note the resistance value. We can write the value as 148.1 ohms. Now in the last part of the experiment, to construct a graph, we will change the value of potentiometer and then we will measure the voltage value across it. We will start with 25 ohms. when the value of resistance is 25.5 ohms, we can note the corresponding voltage value as 0.99 volts. Secondly, we will adjust the value of potentiometer as 50 ohms. Which we can write the corresponding resistance value as 48.5 or 4 ohms, and the corresponding voltage value of the potentiometer can be noted as 1.64 volts. Then the value will be set as 100 ohms. Which we can say it is 98.8 ohms, and the corresponding voltage value can be noted as 2.71 volts. Next, the value of resistance will be set as 150 ohms. Which we can note as 151 ohm. And the corresponding voltage reading can be noted as 3.43 volts. Then the resistance will set as 200 ohms. Which we can write as 197 ohms. Then the corresponding voltage value can be noted as 3.87 volts. Then the resistance value will be set as 350 ohms. Which we can note as 351 ohm. And the corresponding voltage value can be noted as 4.2627 volts. Then the resistance value will be 300. Which we can note as 301 ohms. And the corresponding value of voltage can be noted as 4.55 volts. Nextly, the value of resistance will be 350 ohm. Which we can note as 352 ohms. And the corresponding voltage measurement can be noted as 4.78 volts. Then the voltage value will be 400. Resistor value will be 400. Which we can note as 403 ohms. And the corresponding voltage value across the potentiometer can be noted as 4.96 volts. Then the value of resistance will be set as 4.50 ohms. Corresponding voltage value can be noted as 5.12 volts or 11. Lastly, the resistance value will be set as 500 ohms. And the corresponding voltage value across the potentiometer will be known as 5.24 volts.